Okay, these are the worked solutions to task 3 for algebra stage 5.3. Question 1, simplify the following algebraic expressions. With this one, when you've got a power to a power, you multiply the powers. So it's x to the power of 3 times 2 is x to the power of 6. With the next one, we look at our numbers first and then we'll look at our y's. So each pronumeral at a time. So 10 times 2 is 20. Then we're looking at y to the power of 3 times y to the power of 7, which is y to the power of 10. With the next one, you could do this two ways. You can actually rewrite it as a fraction if you want. Some people find that easier. 25 divided by 5 is 5, and a6 divided by a4 is a squared. Or you could have done it like this. 25 divided by 5 is 5, a6 divided by a to the power of 4 is a to the power of 2. So either way would have been fine there. Now with the next one, with number 4, the way you should do this is probably when we first introduced dividing. That's probably the best way. Look at your numbers first. 4 over 16. 4 over 16 is a quarter. So you're dividing, 4 and 16 both by 4. And then, so that's what we've got with our numbers. And then we've got x4 divided by x to the power of 6. Now, if you think of x to the power of 4 being x times x times x times x, and x to the power of 6 being x times x times x times x times x times x, what are you left with, girls? What are you left with? X what and where? X squared on the denominator. So we've got 1 over 4, that's our 1/4 is for our numbers, and x4 over x to the power of 6, we've got an x squared on the denominator. So, I'm just looking at those separately. Or 4 over 16 is a quarter. And if you want to subtract indices, x to the power of 4 divided by x to the power of 6 is x to the power of -2, but that would have to go on the numerator. Okay? So it is much better for you when you've got higher powers on the denominator to cross off x's in your mind. It is much better. So either you needed x to the power of -2 over 4. What I found is that a lot of people put 4 times x to the power of -2. They had the 4 on the numerator, and it's not meant to be on the numerator. Okay? Sometimes, girls, it's best not to use the rule. For the index laws, it's actually best to use common sense. And the common sense method will take you straight to this answer here by crossing off x's from the numerator and the denominator. 8 minus 12 n to the power of 0. That's 12 times n to the power of 0. A few people made a mistake here. It's 8 minus 12 times 1. It's not 8 minus 1 is 7. It's 12 n to the power of 0. Only the n is to the power of 0, not the 12. So it's 8 minus 12, or take away 12, is -4. Question 1b is to simplify the following expressions without a negative index. So the negative power, 1 over m to the power of 8. Now, a few people made a mistake with this next question. I would be taking care of my negative power first. Negative power means 1 over whatever else you've got, you write it down. 1 over 2y in brackets cubed. Okay, that's what the negative power is, 1 over, puts it on the denominator. So it's 2y cubed on the denominator, which is 1 over. Now 2 cubed is 8. And y cubed is y cubed. So we need it written like that. Now, some people may have done the following. 2y to the -3, 2 to the power of y to the -3. They could have gone 2 to the -3 times y to the -3 if they want, but this is getting complicated now. Why would you do it? All right, each of those is to the power of -3. You can do it like that, but then you need to write that as 1 over 2 cubed times 1 over y cubed. This is all just so messy. I wouldn't do it like that. I would say negative power means 1 over reciprocal 2y cubed, and then just do that normally. If you do it this way, it's just going to be too messy, which is 1 over 8y cubed. So I would not do it this second way. I definitely wouldn't do it like that. This is much easier. A fraction to a negative power, you just find the reciprocal of the fraction. And instead of being to the power of -1, it's to the power of 1. So it's just 7/5. Okay, the next one. You can do this a number of ways. I'd probably just use the index laws. Using the index laws, 3 times 8, they're just normal numerals, is 24. And then you've got n to the power of -6 times n to the power of -2. Using the index laws for multiplication, if bases are the same, add the indices. What do I get? -6 plus -2 is -8. Now that's with a negative index. That is the same as 24 over divided by n to the power of 8. Now, if you wanted, you could have done it another way. Did anyone else try it a different way? I probably wouldn't do it another way, but you could say that that's 3 over n to the power of 6 times 8 over n to the power of 2. That is another way you could have done it. Notice only the n has the negative power, and same here, the n has the negative power. So you could do it like this. 3 times 8 is 24. N to the power of 6 times n squared is n to the power of 8. There may have been a couple of people that did it that way. The next question, I'd probably again just use index laws. 30, or we can try it both ways. So 30 divided by 3 is 10. Be careful here. We've then got y to the power of -6. Remember, we're subtracting indices. So what do I do? Y, -6, what? Take away 2. When you're dividing, if that was +6 and that was +2, you'd go 6 minus 2. Just because it's -6, it's whatever this index is, take away whatever the next index is, and you'd get y, 10 times y to the -6 minus 2 is -8, and you'd get 10 over y to the power of 8. That's one way of doing it. Another way of doing it, I'll do it over here. 30y to the -6 divided by 3y squared. You can rewrite them with positive indexes if you want. That's 30 over y to the power of 6 divided by 3y squared. See, girls, this is getting messy. I wouldn't do it like this. It's getting really messy. You know you can't do fraction divide by a number. You're going to have to do reciprocal of this, and people are going to get all mixed up. This first way really, see, you're really doing y to the -6 divided by y squared. If you look at that on its own, it is this first power minus the second one. It's the better way to go, doing it that way, rather than this way. I'll keep going with this way, but this way is only going to cause problems. So you'd go 30 over y to the power of 6. What? You can't divide with fractions, girls. What are we going to do? Change the... So I wouldn't do this. What I'm doing here is messy. What would I do if I want to do it this way? How do you divide by 3y squared over 1? Times by 1 over 3y squared. We can see how this is getting unnecessarily messy. What do you get now? What's 30 over 3? 10 over y to the 8. I'm hoping I've convinced you to go with the first method. All right. Next page, algebraic fractions. Simplify the following. Denominators are the same, so we simply subtract the numerators. So 8x minus 4x is 4x over 9. In the second one, denominators are not the same. Now, this is not an equation because I don't have equals 8 or equals some number here on the end. You don't go multiplying through by anything. We're just trying to, if the f's weren't there, we'd be just adding fractions. And you do it the same way you would do it in year 7. We're just adding fractions with different denominators. How do we make the denominators the same? You can just multiply the first fraction by 2 over 2. I'm not going to touch the second fraction. So the first fraction will become 8f over 10, and the second fraction remains as 2f over 10. Now it does say fully simplify. 8f plus 2f is 10f over the same denominator, 10, and a few people didn't simplify. 10 over 10 is 1. The answer is F. Okay? Next question. Next question. When you're dividing or multiplying fractions, it doesn't matter whether the denominators are the same or not. When you think of adding fractions, when you were first taught in primary school or in year 7, you needed the denominators to be the same because they were doing it with pies. You know how you had pizza and 1/7 plus 2/7, and then you could say that was 3/7. But when you're adding and subtracting with fractions, it's important that the denominators are the same, right? But when you're multiplying and dividing by fractions, with fractions, it doesn't matter if the denominators are the same or not. So there were people trying to make the denominators the same and got into a real mess. The rule is we change the divide to a times and we flip the second fraction. Keep, change, flip. So keep the first fraction, change the divide to a times, and then flip. We should do some cancelling before we start. You do have a calculator. You could go 12 times 14 divided by 42 if you wanted, but the idea is to do some cancelling. Now we know we've got cancelling with the 7 and the 14, and we know that there's cancelling with the 6 and the 12. So at the moment I've got 4 on the numerator PQ over 1P. And now the P's cancel as well, and we end up with 4Q. Okay, the next question, we don't need to change the multiplication symbol. All we do is we just do our cancelling as we did in the question before. So the 3 and 15, we've got 1 and 5 there because 3 goes into both those. The 4 and 8, we've got 1 and 2. You may not want to do too much on the one line. Let's just write down what we've got now. We've got x squared y to the power of 4 over 10 x squared y to the power of 3 so far. That's what we've got. So I've just cancelled my numbers. I don't want to do too much cancelling anymore at the moment, otherwise it gets too messy. I could have actually cancelled the x squareds if I wanted. I'm now going to cancel the x squareds. They're the same. Now, if you think of y to the power of 4 as y times y times y times y, and y cubed as y times y times y, what are you left with on the numerator? A y over, and then the 10's on the denominator. We're going to use the distributive law to expand and then simplify where possible. In other words, we'll be adding like terms if we can. 5y times 4y is 20y squared. A few people forgot the squared. So that's a positive times a positive is positive, and then a positive times a negative. We're going to get a negative. 5y x squared, you should be putting x squared y, remember alphabetical order, but it doesn't matter if you had yx squared, I allowed it. The next one, expanding, be careful, some people made some silly mistakes here. 5m times 2m is 10m squared, that was one of them. 5m times 1, and they're both positive, is plus 5m. Then we cover up our first bracket. Negative m times m is negative m squared, and negative m times negative 3 is plus 3m. That was another mistake. A few people put take away 3m. And now our like terms are the m squareds. 10m squared minus 1m squared is 9m squared. And then we've got 5m plus 3m is plus 8m. Okay, the next question, fully factorise the following expressions. X is the common factor. X squared is x times x, and minus 9 there. Now, the main mistake with this next one was people didn't fully factorise. Look at each thing one at a time. Look at the numbers, 24 and 8. What's the highest common factor? It's 8. Look at the m's. We've got m squared and m. The highest common factor is an m. So you do one thing at a time. Look at n cubed and n to the power of 4. What's the highest factor? N cubed. That's how you work out your highest common factor. Looking at the numbers, looking at the m's, looking at the n's. Bracket. So we've got our highest common factor out the front. How are we going to change the 8 into a 24? We'll be timesing it by 3. Do we have enough m's? No, we need one more. The n's are good, n cubed. Plus, because it's positive, and that is 2. 8 is the same, m is the same. Looks like we're missing an n. Okay, now some people maybe didn't take 8 out the front, they only took 4 out, or they didn't put enough m's or n's or whatever, okay? If it was a correct incomplete factorization, you got 1. Question 4a, graph the following inequality on the number line. We know we need to circle -1 and 2, but one of them needs to be coloured in, and the one equal to is coloured in. Less than or equal to is coloured in, and x lies between -1 and 2. So open circle on the -1 because x doesn't equal -1, it's only greater than -1, but it's less than or equal to -2. Some people have their shading done incorrectly. The equal one is coloured in. Okay? Solve the following inequality. There are 2 methods to do this. If you want pronumerals on the left, let's take pronumerals to the left, numbers to the right. So we've got 2 take away 4y is less than 6 minus y. So I'm going to keep my minus 4y here on the left. Inverse of minus y is plus y. Remember, I'm just picking up and taking over, adding and subtracting. So the inequality sign doesn't change yet. Keep the 6 here. This is a plus 2. The inverse operation is take away 2. So minus 4y plus y is minus 3y is less than 4. Now I need to divide by -3. So I'm dividing by a negative. That's when the inequality sign gets turned around. So y, I have, instead of a less than, now it's greater than 4 divided by -3. Because I'm dividing by -3. So divide by -3, divide by -3. Notice I've changed my inequality sign once I did that. That's your solution. Y is greater than 4 on -3 or -4 on 3, same thing. The other way you could have done it was to take pronumerals to the right, numbers to the left. So this is the other way, which does not involve flipping the inequality sign. Keeping the numbers on the left, 2, this is a plus 6, inverse operation is take away 6, keeping the minus y here, inverse operation of minus 4y is plus 4y, that gives me 2 take away 6 is -4 is less than, -y plus 4y is 3y. Now, I need to divide by 3, not -3, I'm dividing by 3 now. So the inequality sign does not change because I'm dividing by 3. The only time it changes if you're multiplying or dividing by a negative. Now, notice the big open mouth is facing the y. These are exactly the same. So I can rewrite that as y is greater than -4 on 3. Same answer. Open mouth facing the y. I'm just rewriting. Okay, the next question. Expand and simplify just using the FOIL method or anything systematic so you don't miss out anything. 2x times x is 2x squared. So I just take the first term, multiply it by each term in the second bracket. 2x times minus 5 is minus 10x. Plus 3 times x is plus 3x. Plus 3 times minus 5 is minus 15. And collecting like terms, we've got 2x squared minus 10x plus 3x is minus 7x minus 15. Factorizing the following. I need 2 numbers that multiply to give 24 but add up to give positive 11. 8 times 3 will work. So it's x plus 8 because 8 times 3 is 24 and 8 plus 3 is 11. So it's x plus 8, x plus 3. Part 2. This is x times x plus 3 minus 2 times x plus 3. X plus 3 is the common factor. Once I cover those, what's left? X minus 2. So we take out our common factor of x plus 3 and there is x minus 2 remaining. Now with the next question, solving these quadratic equations. First thing we did was divide by 2. Now this is where you're allowed to divide, so I can go 32 divide by 2. X squared is 16, that gives you 1 mark. But now x is plus or minus the square root of 16. Now a lot of people forgot to put their plus or minus. So therefore x is plus or minus 4. Because 4 times 4 is 16, but -4 times -4 is also 16. Following, we have to factorize it first. So two numbers that multiply to give -8 but add up to give -2, well, it's going to be 4 and 2. One of them needs to be negative, so we've got x minus 4, x plus 2. Let's check that that's correct. X squared plus 2x minus 4x, that works, minus 8. So therefore, 1 mark for factorizing. Therefore, therefore, girls, x minus 4 equals 0, or x plus 2 is 0. Therefore, x is 4, or x is -2. Now, in quadratic equations, generally we factorize. We try and factorize. We'll be doing these again next year anyway. We only touched on them this year. So factorize, put equal to 0. Therefore, the first thing is 0 or the second thing is 0, because if two numbers multiply to give 0, one of them has to be 0. Solving these equations, we're going to expand our brackets. 4 times 3k is 12k. 4 times minus 6 is minus 24 equals 3k plus 6. Let's put all our k's on the left. 12k minus 3k equals 6. Inverse of minus 24 is plus 24. So we've got 9k equals 30. Therefore, k is 30 divided by 9. Next question, part B. When you're solving equations, numbers on their own belong together. So the -7 should go with the 2. So inverse operation of -7 is to add 7. So adding 7, we've got 4m over 5 equals 2 plus 7. Therefore, 4m divided by 5 is 9. So therefore, 4m is 9 times 5, because the inverse of dividing by 5 is times 5. 4m is 45. Now dividing by 4, m is 45 divided by 4. You can leave it like that, or you can write it as, 11 and a quarter. But you can leave it as 45 over 4. The next question. This is fraction equals fraction. You are allowed to cross multiply only in this case, or you can multiply both sides by the lowest common denominator, which is 10. So I'll start with cross multiply. X minus 5 over 2 equals 2x plus 3 over 5. It's an equation and it's balanced. Left-hand side equals right-hand side. So if you multiply one side by 10, it's now 10 times bigger. You have to multiply the other side by 10. All right? So this is a balanced equation. It's saying that the left equals the right. So when you multiply through by 10, if you want to, you are to multiply, because they're balanced. We're making the left-hand side 10 times bigger. We make the right-hand side 10 times bigger. So I'll do multiply through by 10 first. So, and then I'll do cross multiply. So multiply through by 10, because that's the lowest common denominator. 10 times the left-hand side equals 10 times the right-hand side. Now the idea of doing this is that we get cancelling. 10 over 2 is 5. And 10 over 5 is 2. Now that is identical now as if we cross multiplied. So if we decide to cross multiply, but that is only for fraction equals fraction, we go 5 times x minus 5 equals 2 times 2x plus 3. Okay, so I'll continue from the cross multiply bit. So now we've got 5x minus 25 equals 4x plus 6. Putting our x's on the left-hand side, 5x minus 4x equals 6 plus 25. Therefore, x equals 31. You would have got the same thing continuing from there as well. Now, the next question here. We look at this and we say, right, fractions. Equations with fractions. This is an equation because left-hand side equals right-hand side. So I want to get rid of those fractions, denominators of the fractions. Lowest common denominator here is 12. I'm going to multiply through by 12. In other words, I'm multiplying the left-hand side by 12 and I'm multiplying the right-hand side by 12. Does that make sense? Now, I can do them separately. Multiplying the left by 12, multiplying the right by 12. Because this is an equation and it's balanced. All of this equals 5. It's a balanced equation. If you multiply one side by 12, you multiply the other one by 12. Now, there are two things to multiply on the left-hand side. So I'm going to go 12 times y minus 2 over 6 plus 12 times y over 12. I can put little times in there. Equals 12 times 5. I'm multiplying the left-hand side and the right-hand side by 12. Why do I do this? To get rid of the fraction. Now, if you haven't got rid of the fraction after we've done this, then something's gone wrong. So what's cancelling with the 12 and the 6, what do we get? 2 on the numerator. What happens here when I cancel out the 12s? I just get y. And over here, I get 60. Now, a lot of people don't bother multiplying the right-hand side by 12. This is a balanced equation. Think of it as a set of scales. Left-hand side equals right-hand side. If you do something to one side, you've got to do it to the other. Otherwise, it won't be balanced anymore. Think of a seesaw. Now expanding 2y minus 4 plus y. So 2y, take away 4 plus y is 60. 2y plus y, girls. 2y plus y is 60 plus 4. It is not 2y minus y. Look, 2y plus y. And the minus 4, inverse operation is plus 4. So we've got 3y is 64. Therefore, y is 64 over 3. Y is 21 and a third. You can leave it as 64 over 3, no problem. Next, question 6a. If v equals the square root of g on k, find k when v is 6 and g is 12. First thing you want to do is substitute. 6 equals the square root of 12 over k. What's in my way? The obstacle now is the square root sign. The inverse operation of square rooting is to square. So we square both sides. So 6 squared equals, when you square, girls, I'm just putting a squared on both sides. They cancel, the squared and the square root cancel, and I get 36 equals 12 on k. Now, so isn't that opposite of divide by k is times k, or you can just swap them diagonally. It's like when we do trig. If you want, you go 36 times k is 12, therefore k is 12 divided by 36. K is a third, but I just swap those two across the diagonal. Okay? Right, the next one. This is not difficult at all if you just use index laws. Index laws. Power of a power. Don't you just multiply the powers? Negative 2 times negative 8. No. Negative 2 times negative 4 is positive 8. That's the first one. Times. Multiply the powers. X to the power of 3 times negative 2 is negative 6. Over. X to the negative 3 times x to the 5. Now, next index law. Bases are the same when multiplying, add the indices. What's 8 plus negative 6? It's just 8 minus 6 is 2. Bases are the same when you're multiplying, add the indices. What's negative 3 plus 5? It's positive 2. X squared over x squared is 1. Index laws, some other people did this. They didn't want the negative power here or there, so they put the x cubed at the top and they put the x to the 6 on the bottom. That's fine. That's fine as well. Equals x to the 11 over x to the 11, which is 1. That's fine. Okay, sorry, you can't see it. Here, girls, numbers on their own belong together. I would have moved this 4 over to the left and made it 5a minus 1 minus 4 equals a minus 17 over 3. That becomes 5a take away 5 equals a minus 17 over 3. Now that looks like an equation that's quite easy to do now. So we want to get rid of the divide by 3. Inverse operation is to times 3. But you need to times the entire left-hand side by 3. So first thing, numbers on their own belong together. This is a bit of a hard one, all right? That becomes 5a minus 5 equals that. This is now easy to solve. Inverse operation of dividing by 3 is to times 3. We get 15a minus 15 equals a minus 17. So we get 15a minus a equals negative 17 plus 15. So we get 14a equals negative 2. And be careful here because people make mistakes on this simple stage. Negative 2 divided by 14. Divide by 14, which is negative 1/7. Now, that's one way to do it. The other way that people tried to do it was to multiply everything by 3, which is fine. But what they didn't do, they didn't multiply everything by 3. That was the problem. Now, what you will do next time is if you see numbers on their own, you should put them together. But for those that didn't put them together, that's your first step in equations. Numbers on their own belong together. Always do that. Let's say you didn't do that and some people now decided to multiply through by 3. Is that what some people tried to do? Multiply through by 3. Well, you've got to multiply everything by 3. So some people tried to do this, but the problem is they didn't multiply everything by 3. So I need to multiply my whole left-hand side by 3. I need to multiply that 4 by 3. Now that was the biggest problem. People didn't multiply this 4 by 3. And I need to multiply this thing here by 3. So multiplying, you can do these individually. Multiply that by 3 and that by 3. I've done that by just going 3 bracket, multiplying this by 3 and multiplying that by 3. Or you're probably best off just going 3 bracket left-hand side equals 3 bracket right-hand side. So a lot of people forgot to do this 3 times 4. So now we get 15a minus 3 equals 3 times 4 is 12 plus this 3 and that 3 cancel. You get a minus 17 and then we just keep going. Yes, so we get 15a minus a equals 12 minus 17 is negative 5 plus 3. 14a is negative 2. A is negative 2 on 14, which is negative 1/7. Question 7a, Sam is 6 years older than his sister Anna. Claire, Sam's mother, is 3 times Sam's age. The sum of their ages is 44 years. How old is each person? Write an equation and solve it to find the age of each person. We're going to let x equal Sam's age in years. So Sam equals x. X equals Sam's age in years. So if Sam is x, now he's 6 years older than Anna. So Anna must be less than x, so Anna is x minus 6. And Claire is 3 times Sam's age, which is 3 times x. Okay, so just be careful with this one for Anna. We know that Sam is older than Anna, so if Sam is x, Anna is less than that, which is x minus 6. We know the sum of their ages is 44, so we've got x plus x minus 6 plus 3x is 44. And now solving that equation, x plus 3x is 5x, minus 6 is 44. 5x is 44 plus 6. 5x is 50, and therefore x is 10. So therefore the ages of the people, Sam is x, which is 10. Anna is x minus 6, which is 10 minus 6, which is 4. And Claire is 3 times x, which is 3 times 10, which is 30. Question 7b, the numerator of a fraction is 5 more than twice the denominator. Let x be the denominator. Write an expression to represent the numerator in terms of x. So the numerator is 5 more than twice the denominator. Well, twice the denominator is 2x, plus, and then 5 more is plus 5. Next part of the question. So the actual fraction is 2x plus 5 over x. That's the actual fraction. It says when 3 is subtracted from the numerator and the denominator, so we go 2x plus 5 minus 3 over x minus 3, the resulting fraction is 7 over 3. We've written the equation. Now we need to solve it. So 2x plus 5 minus 3 is 2x plus 2 over x minus 3 equals 7 over 3. We can cross multiply here because it's fraction equals fraction. So 3 bracket 2x plus 2 equals 7 bracket x minus 3. So solving this, we've got 6x plus 6 equals 7x minus 21. So I'm going to, so 6x minus 7x equals negative 21 minus 6. So negative x equals negative 27. Swapping sides, x equals 27. Or here you could have just taken your x's to the left and your numbers to the right. So now it says, a lot of people forgot to do this. They forgot to find the original fraction. Well, we know the fraction is 2x plus 5 over x. If x is 27, it becomes 2 times 27 plus 5 over 27. 2 times 27 is 54 plus 5 is 59 over 27. That's your original fraction, 59 over 27. All the bases in this expression are 3. So, first thing I'm going to do, I'm going to change, we've got fraction divide by fraction. I'm going to change my divide to a times and flip the second fraction exactly as it is. So, don't go changing this negative to a positive or anything like that. Change the divide to a times and then flip the numerator and denominator here. Now, all the bases here are the same, so I'm going to use index laws. So, we're multiplying all these. So, it will be n plus 1 plus 2. If bases are the same and you are multiplying, we add the indexes. So, it's 3 to the power of n plus 1 plus 2 plus negative 3 is minus 3 over 3 to the power of negative n plus 0 plus 2n. So, adding and subtracting, n plus 1 plus 2 is n plus 3 minus 3 is just 3 to the power of n over negative n plus 0 is negative n plus 2n minus n plus 2n is 1n. So it becomes 3 to the power of n over 3 to the power of n, which is just 1. Another thing you could have done here was just work this out first. So we've got 3 to the power of n plus 3 over 3 to the negative n, because 3 to the 0 is just 1, times 3 to the negative 3 over 3 to the 2n. And then we could have bases of the same, add the indices, or we could have put the 3 to the negative n up there, 3 to the 3 down here. There are many ways to do it. I probably would have just gone, bases are the same, add the indices. So that's n plus 3 minus 3 over 3 to the negative n plus 2n gives us the same result as before, 3 to the power of n over 3 to the power of n, which is 1. Last question. If 2 to the power of x equals 5, evaluate this. Let's just look at 4 to the power of x first. That's 2 squared to the power of x. Remember, we swap these, so that's 2 to the power of x squared. We know that 2 to the power of x is 5, so that's 5 squared, which is 25. Then we look at 2 to the power of x plus 1. So that's 2 to the power of x times 2 to the power of 1, because if bases are the same, we're adding the indices. We know that 2 to the power of x is 5 times 2 to the power of 1 is 2. So it's 5 times 2 is 10. Therefore, to evaluate 4 to the power of x minus 2 to the power of x plus 1, it becomes 25 minus 10, which is 15. And that's the end of that exam.